Hi all, welcome to the series of Class 11 NCERT Fundamentals of Physical Geography. Let us study Chapter 2, The Origin and Evolution of the Earth. In this chapter, we will learn about early theories about origin of Earth, modern theories about origin of universe, formation of stars, formation of planets, solar system, evolution of Earth, and the origin of life. Let us begin with the early theories regarding the origin of the Earth. A number of theories were put forward by different philosophers and scientists. Among them, one of the earlier and popular one is the Nebular hypothesis. It was put forward by Immanuel Kant, a German philosopher. This hypothesis was later revised by Laplace. In this hypothesis, initially it is assumed that there was a cloud-like material which was made of gases like hydrogen, helium, and dust. It was called nebula cloud. Then, due to rotation, the lighter gases like hydrogen and helium, they came to the center. As shown here, the lighter materials like hydrogen, helium, etc. came to the center and collided. Thus, the sun was created at the center. Now, what happened to the heavier elements? Heavier elements like carbon, nitrogen, and oxygen, they moved away from the center. They moved away from the center and formed nebula clouds around the sun. Around the sun, nebula clouds were formed by these heavier materials. These clouds, on further rotation, came together under gravity and formed the planets. Later, in the year 1900, Chamberlain and Moulton proposed another theory. According to this theory, a wandering star approached the sun. And as a result, a cigar-shaped material got separated from the sun. A cigar-shaped material was separated from the sun. And as the passing star moved away, this material which got separated from the sun, that material revolved around the sun and slowly condensed into planets. This was the theory by Chamberlain and Moulton. Such theories in which the existence of a companion star for the sun are termed as binary theories. Modifications to nebula hypothesis made by Otto, Schmidt and Weizascar. They considered that the sun was surrounded by a solar nebula consisting of hydrogen, helium and dust. Solar nebula is a cloud which consists of hydrogen, helium and dust. Eventually, the friction and collision of particles led to the formation of a disc-shaped cloud like this. Then, planets were formed through the process of accretion. Now, the modern theories consider the origin of universe rather than just considering the formation of Earth alone. It considered the origin of universe as a whole. The most popular theory about the origin of universe is the Big Bang theory. It is also called expanding universe hypothesis. This theory was originally formalized by Georges Lemaitre. In 1920, Edwin Hubble provided some evidence to show that the universe is expanding. Like this, the distance between the galaxies increased gradually. In this figure, the distance is lesser. Gradually, the distance between galaxy increasing, then even increasing. The distance between the galaxy is further increasing. This expansion of the universe occurred because the distance between galaxies increased. Now let us see the stages in the development of the universe. Initially, all matter existed in one place in the form of a tiny ball. The volume of this ball was unimaginably small, and the temperature was infinity, density was also infinity. The tiny ball exploded violently, and there was a huge expansion. At the Big Bang, the tiny ball exploded violently, and there was a huge expansion. I'll tell you once again. Initially, all matter existed in one place as a tiny ball. Then it exploded violently. After that, there was a huge expansion. This happened 13.7 billion years ago, and the expansion is still continuing but slowly. There is another theory which is contradictory to the expansion of universe theory. That is the Hawley's concept of steady state. Steady state means he considered that the universe is always same at any point of time. It is contradictory to the expansion of universe theory. Anyway, scientific community at present favors the argument of expanding universe. Now let us study about star formation. It is believed that stars were formed 5.6 billion years ago. At the time, matter was not uniformly distributed. There were density differences. These density differences gave rise to difference in gravitational forces also. Therefore, matter got drawn together by this gravity. We know a galaxy consists of a large number of stars. Now, let us see how the process starts. A galaxy starts to form by the formation of a cloud known as nebula. After that, gradually the nebula grows and there occurs or there forms some clumps of gas inside the nebula. After that, these clumps will become denser and it will lead to the formation of stars. I'll explain this once again. First of all, a large cloud called nebula is formed. Let this be the large cloud of nebula. This nebula is accumulated with hydrogen gas. Then gradually this nebula grows and develops some clumps of gas like this. Clumps of gas is formed. These clumps continue to grow into even denser gaseous bodies, which give rise to the formation of stars. Now, here is some information about light year. Light year is a unit of length which is used to express astronomical distances. And 1 light year is equal to 9.46 into 10 raised to 12 kilometers. Now, let us study about the formation of planets. Let us see the stages in the development of planets. We already studied that the stars were formed from lumps of gas within a nebula, isn't it? Now, inside this gas cloud, a core is formed due to gravitational force, and a huge rotating disk of gas and dust particles develops around the core. In the next stage, the gas cloud condenses and the matter around the core develops into small rounded objects. These rounded objects, by cohesion develop into planetesimals. So, first of all, the gas cloud starts getting condensed and then the matter around the core develops into small rounded objects. Then these small rounded objects by cohesion develops into the planetesimals. These larger bodies will collide, and due to gravitational attraction, the materials stick together to form larger bodies. Then there are a large number of planetesimals like this, and these planetesimals will accrete together to form the planets. So that's all about the formation of planets. Next is about our solar system. We know all the stars, planets, etc. are formed from a nebula, isn't it? The nebula of our solar system has developed about 5 to 5.6 billion years ago. Now, our solar system consists of Sun, 8 planets, 63 moons, and a number of asteroids and comets, and a huge amount of dust particles and gases. Now, about the planets. The first four planets, Mercury, Venus, Earth, and Mars, are known as the inner planets. These are also called terrestrial planets, where terrestrial means Earth like. The other four planets are called outer planets, that is, Jupiter, Saturn, Uranus, and Neptune, are known as outer planets. These are also known as Jovian or gas giant planets, where the word Jovian means Jupiter like. These planets, the Jovian planets, are actually larger than the terrestrial planets, and they have got thick atmosphere, mostly made up of hydrogen and helium. All these planets were formed about 4.6 billion years ago. Till 2006, Pluto was also considered as a planet, but now it is under the category dwarf planet. Now, the differences between terrestrial planet and Jovian planets. The terrestrial planets are very closer to the sun, that is the parent star. Therefore, it was too warm for the gases to condense to solid particles. Now, the second difference is about solar wind. Solar wind, what is solar wind? It is a stream of charged particles released from the upper atmosphere of the sun. This solar wind was very intense near the terrestrial planets. As they were closer to the sun, the solar wind was very intense for them. So, what happened? It blew off lots of gas and dust from the terrestrial planets. Now, the next difference, the terrestrial planets are smaller than the Jovian planets, and therefore they have got lower gravity. Next is about the formation of moon. One of the earlier theories about the formation of moon was made by Sir George Darwin. He suggested that the earth and the moon were a single body like this. Then as it rotated, it became dumbbell shaped like this. So initially earth and moon were a single body, and as it rotated, it got converted into dumbbell shaped, and eventually it broke into earth and the moon. It is also suggested that the material which got separated from the earth is from the place where we have Pacific Ocean now. But the present day scientists do not accept this. The present belief is on the theory giant impact or big splat. Now, it is believed that moon was formed as an outcome of giant impact or big splat. I will explain what is meant by big splat. A body collided with earth, and as a result it blasted a portion of earth from it into the space. This portion continued to orbit the earth, and it eventually formed the present moon. I will explain once again. The earth collided with a giant body, and as a result it blasted off a portion of earth into space. This portion continued to orbit the earth and eventually formed the present moon. Next is about the evolution of earth. Do you know how our earth looked initially? Like this. It was barren, rocky, and hot. Later, it changed into our beautiful earth with water and atmosphere favoring life, isn't it? Now, we are going to study how this evolution from a rocky, barren, and hot earth to our beautiful planet occurred. Now, we will study about the evolution of lithosphere. Initially, the temperature was very high and Earth was mostly in a volatile state. There were heavier materials, that is, materials with high density, and there were lighter materials also. Then, a process known as density differentiation took place. As a result, the heavier materials like iron moved towards the center, and the lighter ones moved towards the surface. And as time elapsed, it cooled, solidified, and condensed into a smaller size. It is due to the process of differentiation. The earth got separated into different layers. In this figure, these are the layers: crust, mantle, outer core, and inner core. Now tell me, what will be the density of these layers? Yes, the core is the most denser, and the core is the densest, and crust is the lightest. That means as we move from crust to core, the density increases. We'll study more details about this in the next chapter. So now let us move on to the next topic, that is evolution of atmosphere and hydrosphere. There are three stages in the formation of atmosphere. First step is the loss of primordial atmosphere, second step degassing, and third step modification by living organisms. So let us see the first step, that is loss of primordial atmosphere. As I told you before, Earth was formed in close proximity to the sun and therefore it was susceptible to solar wind. As a result, what happened? The initial atmosphere present around the Earth, that means atmosphere containing hydrogen and helium, the initial atmosphere around Earth, it got stripped off by the solar winds from sun. The solar winds from sun stripped off the initial atmosphere of Earth. This is the first step. Now, the second step is degassing. See, from the hot interiors of the Earth, water vapor and other gases got released. Thus, the evolution of present atmosphere started. The evolved gases or the emitted gases involved water vapor, nitrogen, carbon dioxide, methane, ammonia, and a very little of free oxygen. This process is called degassing. Continuous volcanic eruptions took place and this introduced more water vapor and gases into the atmosphere. As the earth cooled further, this water vapor condensed and formed clouds. And as a result, it rained. Rainfall occurred. And the carbon dioxide present in the atmosphere got dissolved in this rainwater. Then the temperature further decreased and therefore more and more condensation occurred and it resulted in more rainfall. Then what happened is this rainfall, water from this rainfall got collected in the depressions on the earth's surface and thus it gave rise to the first oceans. It happened like this. Water got collected in the depressions on earth's surface and formed the oceans. Now, the third step. Life began to evolve, that is, cyanobacteria or blue-green algae was formed in the oceans. As a result, what happened? Photosynthesis occurred, and therefore oxygen got released into ocean water. As time passed, more and more oxygen was added into the ocean, and ocean got saturated with oxygen. Therefore, oxygen began to release into the atmosphere. Thus, the present atmosphere was formed. Now, the next thing, that is origin of life. Modern scientists consider the origin of life as a kind of chemical reaction. It was like a chemical reaction. This chemical reaction generated complex organic molecules like this. After that, these organic molecules assembled in such a way that they could duplicate themselves. Chemical reaction created organic molecules, and this organic molecule assembled in such a way that they could duplicate themselves. It was like this binary fission in amoeba. The molecule was able to, or the assemblage was in such a way that it was able to duplicate themselves. Therefore, inanimate matter was converted into living substances. Fossil evidences show that the first life forms resembled the present-day cyanobacteria or blue-green algae. Now, the summary of evolution of life from unicellular bacteria to modern man is given in this geological timescale. You can read it, and you can also see at which point of time which particular species was formed. So that's the end of this chapter. I hope you understood the class, and if you like this video, please press the like button, subscribe my channel, and press the bell icon to get notifications. All the best for your exams. Thank you.